Hi girls and guys, my name is Michael. I'm working in company Keeper, and today we are talking about Kotlin DSL in Gradle build script. Our plan for next half of an hour. We will start with Groovy DSL as the default way of writing Gradle scripts for now. After this, we will discuss Kotlin DSL and try to discover how it can make our life easier and build script development more effective. And at the end, I will make a small demo with Android project that is using Gradle DSL, and we will convert it into Kotlin DSL. So let's begin. Maybe you know, that Gradle is awesome. Because if you have to build Android project or Java project, you can write a build script file with few lines and everything will work automatically. The only requirement for you is to use conventional directory structure. But when you try to make your build logic more advanced or configure your build in some unusual way, you can discover that there is a bit too much of magic. You don't really understand how it works because it's not so easy. And there are two main sources of this magic. First one is Groovy syntactic sugar, and second one is dynamic nature of Groovy. We will start with sweet part with syntactic sugar. This is an example of basic build script for a Java project. So what we do here, we apply a plugin. We'll talk about plugins in a few moments. We configure it, tell Gradle where to get dependencies, define which dependencies do we need, and create a really simple task that just prints hello world. So, first of all, Groovy allows you to omit brackets. Just method call, space, and arguments. Also, if you pass named parameters into your method, under the hood it's just a map, list of key values. And if method receives a closure as the last parameter, you can move this closure outside of brackets. Nice thing for DSLs. And the last, but definitely not the least, some parts of Gradle build is not a valid Groovy code. In this case, hello is not a valid identifier because we never defined it. So Gradle uses abstract syntax tree transformation or ASC transformation to transform this structure into usual method call, and everything will work. This is how our basic build script looks without all the sugar. Maybe not so clean and shiny, but a bit more understandable from developer's point of view. Now the second source of magic. Groovy is a dynamic language, and Groovy and Gradle, uses this dynamic nature of Groovy a lot. But to understand how, we should look at Gradle build lifecycle. There are three main stages of building Gradle: initialization, configuration, and execution. On initialization stage, Gradle creates a project object. On the next stage, configuration, it interprets our build script and creates a DAG of tasks, or directed acyclic graph. This is a graph of tasks with dependencies, directed dependencies between them. And execution stage. Now Gradle has all our tasks and dependencies between them. And let's imagine that there are tasks with name A, B, and C. And you go to console and type Gradle B. Also, you should use Gradle wrapper, but for now it's okay. And Gradle now also knew all dependencies between tasks, so it can build right sequence for this particular task and execute all dependent tasks. So far, so good. But maybe the most interesting part of Gradle scripts are plugins, because Gradle core without plugins can do barely nothing. And all tasks that we are using to build Android, Java, Groovy projects are provided by plugins. So what is a plugin? Plugin is some class that implements plugin interface that is written in JVM language and overrides apply method. This method receives a project object that was created on initialization stage, and plugin configures this object in some way. For example, it adds a new task, hello in this case. But we need some way to communicate with plugins, to configure them. And for this, we use extensions. Extension is a data class with properties. Plugin register some keyword, greeting in this case, and extension class. And after this, user, in this case developer, writer of build script, can use this keyword to define property values. And after this, plugin can use these user-defined values and do something. In build script, it will look like this. We apply plugin, and we add an extension and some custom value. What's interesting here is that greeting is a method with a single parameter closure with this message property. And this method does not exist in build script namespace before this line. So you cannot call your method before greeting method before this line. And for a statically typed language, this is a problem. You can't compile such code. But Groovy is dynamic, and it allows us to intercept such cases. So if there is no such method, it just call method missing method, and pass in our example, it will pass greeting as name and closure as argument. And after this, Gradle will ask all plugins, hey guys, if someone interested in extension with name greeting, and our plugin will respond, yeah, it's my extension, give it to me please, and I will do something. So there are some issues with such situation of build scripts in Gradle. First of all, there are too much Gradle-specific magic, and it's hard to beginners to understand what is going on. Also, lack of help of IDE, because it's hard and sometimes impossible task for IDE to provide you quality auto-completion for dynamic language, because it can't build code model, abstract syntax tree, and so the only source of truth for you is documentation. You have to know conventions of how you should use plugin. And the last problem, and maybe the most important one, late error detection. To understand that your build script contains some error, you have to just run your build script. And in some cases, for example, with Android project, it can take quite some time. So how we can solve all these problems? Kotlin, because Kotlin is trendy. No, because Kotlin is a relatively new JVM language that uses static typing and has a great IDE support. Because by coincidence, creators of Kotlin are working in the same company as developers of the maybe most advanced Java IDE, IntelliJ IDEA. So Kotlin IDE support is great. But Kotlin is not only statically typed. It also designed with DSL creation in mind. So some of this syntax, groovy syntax sugar for DSLs, Kotlin also can manage it. I remind you how our build script looks in Groovy DSL, and now how it looks in Kotlin DSL. As you can see, difference is not dramatic, and it also looks quite nice and clean. But this is a completely statically typed code, so you have immediate error detection. You have full power of IDE, property renaming, all refactoring stuff, and documentation. Great. But of course, this transition between two languages is not so easy. First of all, because of dynamic, groovy nature. Groovy is dynamic, Kotlin is static, and in some cases, for example with extensions, we just can't compile our code because there is no such methods. Also, there are a lot of plugins that are designed for Groovy, and we should configure it with Kotlin now. So we should have some powerful Kotlin Groovy intercommunication tools. Let's discuss first problem. This is how we define plugin in Android projects now. For this, we use build script section, completely dynamic section where we can use variables. And in it, we tell Gradle where to look for plugins and what plugins do we need. And after this, we apply plugin. And we can apply our plugin anywhere in our build script. And extensions of this plugin will be accessible only after this apply line. And this way of defining plugins is deprecated. Not only for Kotlin DSL, but also for Groovy DSL. If you look at Gradle documentation, you will know that this is true. So Gradle developers proposed new way for plugin declaration. First of all, they created a new format for plugins and new repository. Analog of Maven Central, but for Gradle plugins. Gradle plugin portal. And now you should use a static block. It means that you cannot use variables in it. That is called plugins, this one. And in it, you tell Gradle list of used plugins. Why it is completely static? Because Gradle interprets this section at the very beginning, and all plugin extensions will be available anywhere in your build script. But of course, there are a lot of plugins that are not in the repo yet. And we have to work with them too. So for this, we use a workaround. Let's go back to build lifecycle, and particularly to configuration stage. For now, we write our build script, but we just add apply lines. And don't add extensions to our build script. After this, we call special task that will build our dynamic environment and all dynamic entities in it, for example, extensions. And this task will take a snapshot of all these dynamic entities and serialize it into some file. After this, Gradle will generate extension handlers, just methods, with the same name as extension keywords, and add them to your build script namespace. And after this, you can use this extension in your build script. With a new plugin definition system, you can skip this step, and Gradle will generate extension handlers automatically. Not instantly, but after 5 seconds, it will. This is how serialized version of environment looks like. Conventions, the ancient way of configuration, plugin configuration. Configuration, let's skip it for now. And extensions, the most interesting part for us. In the case of Android projects, there will be Android line and Android extension class. This is how generated code looks like. So for Android plugin, it generates property and method that receives a closure, configuration closure. And you can use it in your build script. And this is how this special Gradle task is called, Kotlin DSL accessor snapshot. And result of this task is a project schema JSON file in Gradle directory in your project. So the recipe is easy. Apply a plugin, but not add an extension yet. Call snapshot task, use extensions. So Android, maybe the most interesting part for us, because vast majority of us are Android developers. So first of all, Android plugin is not in this plugin repository yet. And in the nearest future, I mean couple months, it will not be there. Also, Android plugin is a little bit tricky. I explain why on demo. And there are some not supported plugins, plugins that cannot be configured with Kotlin DSL. I have tried to migrate my main project to Kotlin DSL and discovered that plugins that we use for publication of APK to Play Store, Gradle Play Publisher, popular plugin, it adds configuration to Android extension. So it adds new dynamic entity to a dynamic entity. And it's too much. So you cannot use this plugin with Kotlin DSL. And we should wait for that someone will fix or just re-implement this plugin and adapt it for Kotlin DSL. For our project is a blocker for now. Demo part. For demo, I prepared a really basic Android project. I just created it with Android Studio Wizard. So there are two build Gradles. First one in root project, where we define our Android plugin. Second one in app sub-project, where we configure Android plugin and apply it. So let's start. First step of any migration is renaming. We should rename our build Gradle files into build Gradle KTS, or Kotlin script. Studio will show you warnings that this is impossible, but it's not true. Don't believe it. It's possible. And I should tell you that developers of Kotlin DSL and Gradle overall are in a step ahead of developers of IDE. So tools, I mean IDE, not always work in proper way. So sometimes you should force it to do something. So for now, I will comment this to simplify our situation and return to our main build script. So as you remember, Gradle DSL and Kotlin DSL are quite similar, so we can reuse keywords from from Gradle DSL in Kotlin. And autocompletion works. It's good. But there are three different options for a build script. Two of them are from Groovy world. And third one is from Kotlin. Looks nice. You can determine that it's from Kotlin. So with repositories, same situation. But in this case, it adds import even. And we are done with this section. In Kotlin, we cannot use apostrophes for strings. So first of all, you should replace all apostrophes with double quotes. Also, in Kotlin, we cannot omit brackets. We added brackets. And now we are ready. Don't believe that this is an error. I tell you that it is not. And we are ready to synchronize our IDE with build script. As you can see, I was right. And now we are ready to proceed with our second build script. And now, as you maybe remember, we should just apply our plugins and call special snapshot task. Let's do this. So, apply autocompletion. Please work, yeah. Plugin. Also, we have plugin. And as you can see, we also have a full documentation. It's quite cool. Yeah, we have 3 plugins. And again, we should replace all apostrophes double quotes and use multi-cursor because it's trendy. We are ready to call our special snapshot task. Here it is. Let's try. Something wrong. Compile SDK version is not specified. Maybe you know that compile SDK version is one of configuration properties of Android plugin. And usually, plugins don't require any configuration to be just applied. But Android plugin does. And Googlers know about this problem, and they even plan to fix it in Android plugin 3.1. But not yet. So we should find some workarounds for this, and we have ugly workaround for this. It looks like this. Configure method that is parameterized with Android plugin extension class, and we should add it to our build script and call our task again. Build successful. Cool. So now we have project schema in our Gradle directory. So this is how it looks like. Conventions, configurations that are added by Android plugin, and Android keyword. Now we can use it in our build script. Let's try. And sync again. Cool. Is it the completion works? Yeah. So there is an Android extension with full documentation, with full auto-completion. Cool. We are ready to proceed with other blocks. So default config and build types. Don't need this anymore. Uncomment. Indentation. So, default config. Let's try to understand what's going on with help of auto-completion. So, there is two methods, getApplicationID and setApplicationID. And in Kotlin, if we have getter and setter, we can use property access syntax. So we can just use equal sign. And I believe that in these cases, we also can do this. With min decay version, situation is a little bit more complicated. Auto-completion will propose us to use as API version. You can see it, but believe me. And also there is a method that receives integer number. Okay, so let's use it. As you can see, auto-completion helps. You now should not Google. You can just use auto-completion. With build types, situation is another. So release is also dynamically generated entity. And build types is so-called domain named collection. So we can get entities from this collection with method get by name. Help me, please. Yeah. And use release as just a name, just a string. Works. So minify enabled. We have two methods here, isMinified enable, setMinified enable, so we can use an equal sign, proguard files. There is a method with variable arguments. We will use it. So we are ready. And the last section is dependencies. Implementations now is a method, so we should add brackets to them. You maybe remember that in Groovy, when we use named parameters, it's just a map. So in Kotlin, we can use map of and to keyword to create a map. Same with include. And square. Oh, let's add some new lines. With square brackets, it's also Groovy syntactic sugar because there stands for list. And in Kotlin, we define list in this way. And I believe we don't have one bracket. Yep. List of, list 2y. Yeah, cool. So now our build script looks like it is ready. Sync. And OK, cool. Let's try to run our application. I already started up an emulator. So let's see. As you can see, it works. We are done with our demo part. And thank you. It was really nervous part because of summary. Tools are in alpha, beta state, something like this. So in sometimes they lie you. Sometimes you should force or even restart Android Studio, but they are usable. And also they are usable with Android project. And I cannot recommend to migrate whole build Gradle to Kotlin DSL yet. In half of a year, I think I will recommend, but not now. But you can choose risk-free way to try Kotlin DSL. Just add new build script KTS file and include it into Groovy build script, because Groovy and Kotlin DSLs are absolutely compatible between each other. But please remember about incompatible plugins. Anyway, you should try it, because when it works, it's like a magic. You have all auto-completion stuff, documentation. It's really comfortable to work with your build script. And you understand what's going on. It's a pleasure. So there is a screen with this ugly workaround. I hope that when Android plugin will be remade a little bit, we will not use them, but for now we should. And this is sources that I used in my presentation. The most interesting one is first one, Kotlin DSL GitHub repo. They have documentation. You can find documentation in release notes of Kotlin DSL, not in wiki or README. And also there are a lot of samples of a Gradle project with Kotlin DSL. Yeah. So just there is also an Android sample. You can use it for your experiments. It's all. Thank you for your attention.